We're going to talk about graphing relationships today and analyzing some graphs. As a warm-up, I want you to think, when I say this, tell me whether you think of something increasing, decreasing, or being constant. Stays the same, constant. Rises, increasing. Drops, decreasing. Slows down, decreasing. Those are the kinds of things that you're going to need to look for. Make sure that you can tell me the difference between a continuous and a discrete graph. Here's an example. Each day, several leaves fall from a tree. One day, a gust of wind blows off many leaves. Eventually, there are no more leaves left on the tree. Choose the graph that best represents this situation. Pause the video if you need to. Take a good hard look at this and decide which of one of these represents that. What we're going to do, we're going to read the graphs from left to right to show time passing. Okay, so look at each one of these and say, all right, what's happening here? This is time ticking along. Looks like leaves are increasing, staying the same, all falling off. Going down sharply, going down even further. Going down, staying the same, going down. So we're going to look for key words here. Okay, each day several leaves fall. Never horizontal. Never horizontal. The only graph that does that is graph B. Wind blows off many leaves, slanting downward rapidly. All three of them start with a downward slant. Eventually, no more leaves, slanting downward until it reaches zero. All three of them do that. B is the only one that tells the whole entire story. Okay? Never horizontal, slanting down rapidly, all the way down. All right? Let's see what this one says. The air temperature increases steadily for several hours and then remained constant. At the end of the day, the temperature increased slightly before dropping sharply. Choose the graph that best represents this situation. Again, pause the video, look at the graphs from left to right. This is time going on, and see which one of those represents that. If you picked graph C, you're correct. As seen in the example that we did first, some graphs are connected lines or curves. Those are called continuous graphs. Especially when you have time. Time, you get every single second, every little part of it, you have something happening. There are other graphs that are only distinct points. Those are called discrete graphs. Here's an example of a discrete graph. The graph on the theme park attendance is an example. It consists of distinct points because it's number of people. You count people as whole numbers. You can't have 2.5 people or 5 3/4 people. So you have to put individual dots, and that's what makes it discrete. If this was connected, a connected line, that would be continuous. Okay? All right. What I would like for you to do is pause the video. I would like for you to sketch a graph for this situation, and then tell me whether it is continuous or discrete. A truck driver enters a street, drives at a constant speed, stops at a light, and then continues. So I would like for you to draw that. Okay? So a truck driver enters a street. I have to assume that he is moving at the time. Okay? And so this is going to be his speed probably, and this will be time. So he enters a street, drives at a constant speed, stops at a light, and then continues. I'm going to say something like that. What does yours look like? Is it close? All right, try this one. A small bookstore sold between 5 and 8 books each day for 7 days. So, again, pause the video. Do that. I'm going to say days down here. I'm going to say books here. And then what do you think this is going to look like? Can you sell a half a book, quarter of a book, tenth of a book? Okay, so on day 1, let's say we sold 5 books. On day 2, let's say we sold 8 books. Day 3, let's say we sold 6 books. Okay? All right. This is kind of interesting. Both of these graphs show a relationship about a child going down a slide. They both have time on the bottom. That's your independent variable. That's the one that's just going to happen, there's nothing you can do about it. That's going to change, okay? One of them represents the distance from the ground. The other one represents speed. Take a good look at those. I'm going to ask you a question about those in just a minute, okay? I'd like for you to look at this and write a possible situation for this. You've got time, you've got speed. Okay, again, analyze the parts. What happens here? Looks like the speed is going down. Then what happens? Remains constant and then decreases to 0. So see if you can come up with a situation for that. Here's another one. All right, analyze it. What do we have? Students here, pizzas bought. Looks like one pizza. Then what happens? All of a sudden we need 2 pizzas. Interesting. Okay, what about this one? Got time on the bottom. We've got height here. Think of something. What would you start at some height, then increase a little bit more? So I'm thinking maybe somebody is standing on a porch, all of a sudden climbs up a ladder onto the roof and jumps off. Just a thought.